Okay, so far we have discussed up to the properties of ionic compounds in the last video, right? So let's start a new topic, occurrence of metals. So we have been discussing different kinds of properties of metals and non-metals, their behavior, how they form compounds. All these things have been discussed, right? Now, how metal occurs, right? That means how metals are found in the earth crust. So I think you have heard the term like mineral ore, right? So mineral means what? Naturally existing form of an element or compound, right? That means how naturally in the earth crust they are found, the elements are found. This naturally existing form is known as minerals. Okay, now now you see, when we are going to extract any metal, obviously mineral means what? Here metals are present, right? Because how they are found in the earth crust normally or naturally is the mineral. So when we are going to extract any metal from this mineral, now we must get the profit, right? If we don't get the profit, then what is the need to extract it? If we are going to extract it, there must be some benefit, advantage must be there, right? Now from these all minerals, it is not possible to extract a metal profitably. So those minerals, that means some particular minerals from which we can extract a metal profitably, then that mineral is termed as ore. Okay, so the minerals from which we can extract a metal profitably is known as ores. So in one line we can say that all ores are minerals, but all minerals are not ore, right? So if sometime it is asked that explain this term, that all ores are minerals, but all minerals are not ore. Okay, so now we have got that whenever we are going to extract a metal, then we will consider the ore only. Okay, now let us go through the mechanism, through the procedure by using which we can extract the metal. Now while we are going to extract the metal, we have to remind that reactivity series, that is their metals reactivity. On the basis of their reactivity, we will implement the procedure, that means which will be applicable, right? Now once you remind that period, that is reactivity series, that means from high reactivity towards what? The least one, that is from top to bottom. One reactivity chart was there, which was discussed in the previous video, right? Now on the basis of that reactivity series or that reactivity chart, we can, that means what, we can separate or we can isolate them into three categories: metals of low reactivity, metals of high reactivity, and metals of medium reactivity. That means some metals will be there whose reactivities are low, so they would be termed as metals of low reactivity. Then those who are in moderate state, they will come under medium reactivity, and those who are highly reactive, they will be categorized as metals of high reactivity. Now on the basis of these three category, we will apply the technique so that we can extract the metal. Now you know that those metals which are at the bottom of the reactivity series, they don't have much tendency towards the reaction, right? That means they are almost what, stable type or inert type. That means what, they don't try to react easily with any other substance. So they are found at the bottom of the reactivity series, it is known to you. Now mostly the metals are found in three forms, that is their oxide, then their sulfide, and their carbonate form. That means from these three forms it is easier to extract any metal. Most of the metals are found in the oxide form. okay. And because from the oxide form it is very easy, or through a single step we can get the metal, right? Besides this, some factors are there. Suppose oxygen is what abundant, and it can get what it has the tendency to react with most of the metals. That's why oxide of various most of the metals are formed. So that means what, actually main procedure would be applicable for the middle one only, that is those metals which are at the middle of the reactivity series. Suppose you see here, those who are at the top of the reactivity series like potassium, sodium, calcium, magnesium, aluminium, they are at the top of the reactivity series. Those who are in the middle like zinc, iron, lead, copper, then silver, gold, bottom of the activity series. So on the basis of this, just focus on this chart, that is a figure number 3.10. first you see ore, okay, concentration of ore we have taken. Now they have been categorized in these three forms, separated, right? Metals of high reactivity, medium reactivity, and low reactivity. Now those metals whose position at the bottom, that means towards bottom, or those who are of low reactivity, they are mostly found in sulfide form, that is their sulfide ores are found, okay. Now if it is the sulfide ore, then we will go through a process known as roasting. We will come to know about roasting later, okay. So roasting, after the process of roasting we will get the metal, then refining would be there, okay. That means up to this we will get the metal. Now if they are in medium reactivity, suppose you can take example like zinc, iron, lead, their position in the middle of the reactivity series, right? Now if they are in medium reactivity, then they are found in these two forms, carbonate ore and sulfide ore. Suppose if you have taken the example of zinc, suppose, then zinc is found in sulfide ore form as zinc sulfide, and in carbonate ore form it is as zinc carbonate. Now if it is sulfide ore, then we will go through a process known as roasting. After roasting we will get the oxide of that metal, okay. Again you see, if it is carbonate ore, then we will go through a process known as calcination, then we will get the oxide of metal. After obtaining the oxide of metal, there will be the reduction to that metal. That means after obtaining oxide of metal, through a simple reduction we will get the metal. This is about middle. Now if they are in high reactivity series, suppose sodium, potassium, then we will go through a process known as electrolysis. There is electrolysis of molten ore. Suppose if it is sodium chloride, where sodium is present, right? And sodium is what, highly reactive metal. So what we will do, we will do the electrolysis of molten sodium chloride to get the pure metal. So this is the procedure we are going to apply to extract metal from its ore, okay. Now let us discuss in detail by taking the example how they have been extracted and how they are extracted. Okay, thank you for today.